Hi. So this video, we're going to be working with solving word problems with vectors, right? Most of the word problems are going to involve two or more forces applied to an object, with the questions being the magnitude and direction of the resultant force. Methodology to solve this problem is as follows. We're going to write each force as F1 cosine of theta I. So the force is going to be the magnitude of that force, and sine theta of j, right? So we're going to write each force that way. So it's the magnitude of the force applied times cosine of the angle I plus the force times sine of the angle j. We're going to add each component. So we're going to add the i's with the i's, the j with the j, and that's going to give me a resulting vector in the way of ai plus bj. The magnitude of that resultant is going to be the force, the total force, right? And then the direction is going to be the opposite of tangent, or the inverse of tangent, so b over a, where b is this value and a is that one. Let's see this one. Says, I push a heavy desk by applying a force of 150 pounds at 25 degrees to the desk. How much force is actually used in pushing the desk? So in this case, I have just one force. So in that case, let's make the drawing right here, right? So I got one vector that goes something like that, right? Where the angle, and let's draw this right here, this angle here is 25 degrees, right? So, and the force that I have right here, this force is 150, and I want to know how much force is actually applied. So I'm actually looking for this side. On this case, because it's just one force that I'm going to apply, I'm going to close this right triangle here, and I can use simple solving a right triangle, so I told here, where F equals to 150 cosine of 25, right? Because it's adjacent over hypotenuse. And we're just going to go to our calculators to find that. So 150 cosine of 25, and that equals to 135.95 pounds. So it's asking me also what's happening if I increase the angle to 35. So now instead of being 25 here, instead of being 25 right here, of being 25 is just going to be 35 degrees. So again, I'm doing the same. So it's going to be F equals to 150 cosine of 35 degrees. So 150 cosine of 35. And that equals to 122.87 pounds, not degrees. Right, so pounds. The next one says, two tugboats are pushing an ocean liner at an angle of 17 degrees to the liner, to the northeast and to the southeast. What is the resultant force of the ocean liner? Both boats pull with a force of 500. So let's start by drawing here my x-axis, all right? And I have one of the vectors going northeast, 17, so it's going to go something like that, right? And this is the 17 degrees. Now the other one, I'm going to add it here at the end. Remember when we saw the addition, we put one vector on top of the other one, right? Or one vector not on top of the other one, so one vector after the other one. So from here, I'm going to draw my other one that is southeast. So I got this. So I got this angle right here. And again, of course, this is not done to scales. It's 17 degrees, right? And my resultant vector is going to be something like this vector that I just draw here, right? Where this is 500 and this here is also 500, right? Now, remember that the angle that I'm going to use here for this formula is going to be drawn always with the x-axis. So this angle right here is 17. So that means that I got 500 I cosine of 17 plus 500 j sine of 17. Now let's look at the angle for the next one. So the angle again is with the x-axis. So it's that one down here, right? So it's this angle right here, this angle right here. So that means that I'm going to write this right here, F2 equals to 500I cosine of negative 17, because now I'm opening this angle clockwise, right? So negative 17 plus 500 J sine of negative 17. I'm going to add those two to find the force, or to find my total force right here. So that means that I got 500 cosine of 17 plus 500 cosine of negative 17. And that's going to give me 556.3 I. And then the other one cancel out, right? Because this cancel out in this case, because when we add it, I got 500 sine of 17 plus 500 sine of negative 17. That give you 0. Right? So now I'm going to find the magnitude. On this case, the magnitude is easy because once I have just one element, right? One, either I or J, if I just have one, it's the same, right? So I have 556.3 tons. Okay. The next one says 2 people are pushing a piano. One person pushes with 177 pounds at an angle of 60 to the x-axis, while the other pushes with 250 pounds at an angle of 30 degrees to the x-axis. So again, let's start drawing here like a small x and y axis. This first one is going to be 60 degrees, so it should go something like this. So this angle right here, because it's telling you that it's to the x-axis, is 60 degrees. From here again, I'm going to draw this, and it's telling me now 30 degrees to the x-axis. So I got it something like this. And the 30 degrees is here, right? And again, my resulting vector is this vector that I have right here. Right? So again, this is 175, this is 250. So let's write the forces. So force 1, I'm going to write this as force 1, this vector right here. So it's equals to 175I cosine of 60 plus 175J sine of 60. Then the force 2 is this vector right here, right? So force 2 equals to 250 I cosine of 30 degrees plus 250 J sine of 30 degrees. Okay? And I'm just going to go to my calculator and add 175 cosine of 60 plus 250 cosine of 30. And that's going to give you 304.01 I plus, and then 175 sine of 60 plus 250 sine of 30, and that's going to give you 276.55 J. Okay? And again, I'm going to find the magnitude here so I can find the total force here. So my magnitude is going to be 304.01 square plus 276.55 square, and it's the square root of that. So let's go to the calculator. So 3.01 squared plus 276.55 squared. And that's going to give you that the total force here is 407.57 pounds. Right? Now, let's see why it's tangent. Again, my resulting vector, so this vector that I have here is this purple vector that I have right here. Right? If I close that triangle and find this angle here is theta. Right? So because this is going to be y, this is going to be x, that means that that's y, right? If I have that right triangle, theta is going to be tangent, opposite over adjacent. So that means that theta here is the inverse of tangent of 276.55 divided by 304.01. And I find that on the calculator. So the inverse 276.55 divided by 304.01, and that's going to give you 42.29 degrees. Okay, the next one says I'm in a motorboat crossing a river with a current of 4 miles per hour. The motorboat travels perpendicular to the current at 12 miles per hour. What is the resultant speed of the boat, and at what angle do I hit the opposite back? I have my motorboat that goes, let's say, like this right here, right? So it's going up here at 12 miles per hour, right? I have the current right here, right? Again, I'm going to add that at the end, right? So this is 4 miles per hour. Actually, I'm going to move this from here and put it on the other side. 12 miles per hour, right? And I want to know that angle, and this is my resultant vector right here. That's the direction where the motorboat is actually traveling after I'm traveling at 12 and it hits by the point, right? And the angle that I'm finding here is this one over here, because in this case, this is telling you here that is what is the angle that is the opposite river bank. So let's start by finding this right here. Start by finding this again, force one. Let's name this with force one. So S1 here. So F1 equals to 12 I. And in this case, it's going to be cosine of 90, right? Because this is going to be 90, right? If I draw my my axis, this is also 90. So that means that I get plus 12J sine of 90, right? And now force 2, again, is 4I. Now, on this case, again, I'm drawing that x-axis right here. That means that, on this case, my angle is 0 plus 4J sine of 0. We know that cosine of 90 is 0, so that cancels out. And we know that sine of 0 is 0, so that cancels out. So cosine of 0 is 1, sine of 90 is 1. So that means that my total force here is 4I plus 12J. The speed of the boat is going to be 4 squared plus 12 squared and the square root of that. So again, the square root of 4 squared plus 12 squared, and that equals to 12.65 miles per hour. Right? Now, look at the drawing, right? It's asking me for the opposite bank. So if you can see that we have a right triangle here. So that means that theta equals to the inverse of tangent of 4 over, or 12 over 4, sorry, 12 over 4. 12 over 4, right? And it's the same that we have here, right? It's 12 over 4. So that means that I got the inverse of tangent of 3, and that equals to 71.57 degrees. Let's see the last one here. So a plane is traveling 500 miles per hour called airspeed in the direction of 150, encounters a wind of 80 miles per hour in the direction 45. What is the resultant speed called ground speed and the direction of the plane? So let's start by reviewing the direction. We always, on this case, that direction, we're always drawing it from the north line, so from up here, right? So from here is where I'm drawing that 150 degrees. Right? So 150 should be somewhere down here, right? Where this angle in here is 30 degrees, right? Because again, I went 150 from here. I went around 150, so I'm missing that 30 degrees to get to the 180. Now, from here, also I'm going to draw my wind that it goes, let's draw another X and Y axis here, right? My is going 45 degrees, so that means that it's going this direction right here, right? Where my 45 degrees is this one down here, where my 45 degrees is that one. Okay, so now my resultant vector is going to be this vector that I'm going to draw right now, approximately this vector right here. So let's keep in mind that my angles are going to be from the x-axis. So that means that my angle that I'm going to use to put on the formula is this angle that I'm marking here, this angle right here, right? So that means that I got 270 until here, and then 30 more is 300. So the angle that I'm using for force 1, so F1, is going to be 300. So I got 500 miles per hour, so 500 I cosine of 300. And again, that 300 comes from, right? I'm using the 150 just to draw the angle down here, draw the vector. the angle that I'm using here, I'm measuring from the x-axis, so I go around here, right? 270 plus 30. Or I can see also that from here, I got 90 to here, and I'm missing 60 more here. So 360 minus 60 is 300, right? Plus 500J sine of 300 degrees. Now the force 2, that is the wind on this case, this is 45, right? Actually, my 45 original 45 angle was here, but then this one is also 45, so we can complete that 90. So in this case is 80 I cosine of 45 plus 80J sine of 45. And I'm just going to add there, so 500 cosine of 300 plus 80 cosine of 45. That's going to give me 306.57. And then I have 500 sine of 300 plus 80 sine of 45. That's going to give me negative 376.44 J. Okay. So I'm going to go here. So the speed is going to be 306.57 square plus negative 376.44 square. The square root. So I get the square root of 306.57 divided by, or square, plus negative 376.44 square. That's going to give you 485.48 miles per hour. Now to find the angle, again, my angle, in this case, right, my angle, so theta equals to tangent negative 376.44 over 306.57. 57. So tangent of negative 376.44 divided by 306.57. That's going to give you 50.84, negative 50.84 negative degrees. Right? Now, but it's asking me for the direction. So the direction, remember that we measure it from here, right? And I know that this joint is definitely not made to scale because this should have been, let's erase something here. This should have been smaller. So that vector, that resulting vector could go a little bit, we can see a little bit different, right? So this is the vector here. My resulting vector should go somewhere around here, right? Let's draw this right here. This angle here is the negative 50.84. This angle right here, right? Now, I'm finding a direction, so I'm going from here, that is the 90, plus this small piece here, right? So my direction is going to be 90 plus that 50.84, right? And that's going to be 140.84 degrees. The reason why we take the positive, because again, I'm going to start measuring here. This is 90 to here, and I need that 50.84 down there. And that's it for this lesson. May the force be with you.